Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Bommer BB5064 545ETW04 652. That means that this is an electrified through-wire hinge. It's for all intents purposes, it's a fairly garden variety hinge. It's a 4-wire electric power transfer hinge. It's not electrified. There's nothing electrified about this. But it does transfer power, of course, because it has its wires on the back. And this is kind of what this looks like. And I said earlier, this is garden variety. An electric transfer hinge is certainly garden variety. This hinge is certainly less than garden variety because it's a heavyweight hinge. And it's really a great example of product from Bommer, and I am an unapologetic, unabashed fan of Bommer. I like their people. I especially like their people, their quality, and we'll get into all of that. But this video is going to be from the perspective of someone who prefers Bommer as a manufacturer. So what's really, great about the hardware industry is, you don't really have to know the part number. You just have to get to the table that says how to order it. And that's the saving grace of material like this. This is a relatively simple part number. There's not a lot of pieces and parts to it, but I don't remember what all of the different individual code sections mean. And starting with a dissection of the part number is the way that we go about understanding exactly what it is we have. And I'm going to, and we're going to start with that right now. Okay, so the hinge that we're dealing with here is a BB. That's easy. It stands for ball bearing. You can see that the bearing packets are here. This also means, BB stands for ball bearing. That's easy. The 5 in the part number stands for a number of things. It's a 5-knuckle hinge. Well, the rest of the part number does. If you see right there, clearly it's a 5-knuckle hinge. The 0 tells us it's full mortise. That means when you bring the leaves parallel, they're meant to be mortised flush to the edge of the door and frame, and that's a result of the swag that's on the hinge leaf right here. From the back of the barrel to the hinge leaf. That's called the swag, right at the very center of my finger. Okay, that's the swag line. Depending on how this hinge is swagged, it will change the type of hinge. Okay, full surface versus full mortise. Well, a full mortise hinge will look like this. A full surface hinge will have no swag, and those leaves will actually be flat along with the barrel of the hinge. Okay, so this is a full mortise hinge, and that's what that 0 means. 6 in the part number stands for electric. It's an electric transfer hinge. And then the 4 in the part number after that means two things. It means it's made of steel and that it's heavyweight. The telltale sign that it's heavyweight were those 4 bearing packets. A standard weight hinge will have only 2 bearing packets. A 5-inch heavyweight hinge is going to be 190 thousandths, and my caliper tells me 0.19 on the nose. Not that it matters if it was, 2 thousandths heavy or light, but this is on the nose, 0.190. Hinges from other manufacturers are never exactly 0.190. This is 190. So that covers the BB5064 is what this part number. Ball bearing, full mortise, electric, heavyweight, steel-based. It means all of that. After that, we have 545. 545. Bommer's system of sizing hinges, even I still need to refer to the chart every once in a while, because sometimes a 4.5 by 5 or, something unusual I need to look up and say, how do they size that again? I had one that I don't recall what it was, but I needed to ask how to call it. 5 by 4.5. 545. It's 5-inch tall and 4.5 wide. It's absolutely crucial to understand that the height is indeed the first dimension on a hinge like this. Why is that important? Well, it's important because this is a hinge that's rectangular. If you were thinking that the hinge was 4.5 inch tall, and you ordered 5 by 4.5s, it would not fit. The height is the first dimension on a hinge. The height is the second dimension on a door. That doesn't make any sense. It's not even helpful. But as I've thought about it over the years, the first dimension, what do you put in the heading of detailing an opening? The information that must be there to convey to a third party, this is what's unique and important about this opening. So you get that up there in that small amount of real estate that you have. What's got to be there has got to be there. I liken the first dimension to be the one that's slightly more important. Or if there was going to be one more important than the other, I would say it's the first dimension. In a door, what's the most important dimension if you had to say one? Well, the width. What size door are we dealing with? People don't say 8.0. Okay, great, it's an 8-foot door. That doesn't help. What's the width of the door? So I think the first dimension is the one that's more important than the other, even though they're certainly important because they must be put into a complete context. With a hinge, however, the height is actually more important, even though the second dimension, the width, is incredibly important. But the height is really important because it tells you what you're prepping in the door and frame. Okay? It also tells you the sort of capacity that the hinge can handle. So this is a heavyweight, ball-bearing, 5-inch tall, 4.5 wide. That tells me that they've got an awfully heavy door. They've got a door that is calling out a 5-inch height. Best standards could say anything bigger than wider than 3 foot, and certainly 3'6" and wider, best practice would have a 5-inch tall hinge, even though the width would still be just 4.5 or even 4-inch. We'll talk about that in a moment. Because the difference between a 4.5-inch tall and a 5-inch tall hinge is about a 20% increase in the hinge's ability to handle the weight rating. Okay. Now, you're dealing with a through-wire hinge. Through-wire hinges are technically not load rated. So you're certainly going to want to have your other hinges obviously match this because they'll need to in terms of the width and the thickness. But realizing that the ability of this hinge to carry the weight, the load of the door is already compromised because they've drilled holes in the hinge leaf, okay, to run wires through. It makes sense that this is a heavyweight hinge that's 5-inch tall. So when you have wider doors, 3'6" and wider, yes, you're going to see 5-inch tall hinges. That would be best practice. If you have a heavier door or just a door with high volume, a 3-foot door that gets used 1,000 times a day, you're going to want heavyweight hinges. So I think, to me, that's why the height is the most important dimension, because it tells me a lot about what's going on with the door. Is it average, garden variety, or is there something unusual about it? Yeah, 5 by 4.5, that's heavyweight, ball bearing. Yeah, that tells me that something's happening there that I need to know more about. And that's why I think it's most important in that regard. Access panels. The hinge is on the second dimension. So if you ordered an access panel that was 24 by 36, the only thing that you have to know is the hinge is on the 36-inch dimension. You can put the hinge vertical or horizontal. That's your call. It would normally be vertical. But there's always a dimension that has some sort of paramount status over the other dimension. And I think that's why they put it first. When it comes to a hinge, the height is pretty important. So really a great hinge. Let's move on to the width. This is a 4.5-inch hinge. 4.5 is important to know because, well, that's the standard width. But determining the proper width of the hinge should not be just left to, well, that's the size we always use. 4.5 may not be the right size or the correct size to use. You might need a wider hinge. You might need a 5 by 5. You might need a 5 by 4. A 5 by 4.5 tells me that we're still dealing with an 1 3/4 thick door. A 5 by 4 would tell me that we're still dealing with 1 3/4, but a 5 by 5 would tell me that we're dealing with a door quite likely thicker than 1 3/4. Okay, so both of those sizes tell you something. Let's do a little deeper dive into this width condition and help you determine exactly what it is that you should consider ordering. Let's do that. Let's switch to the screen view for that. So here is the item that we're looking at, and we're going to move this discussion to talking about the width of the hinge. We've pretty much covered the height, but the width of the hinge is important because you have, you know, possible scenarios where you need to really be mindful, be aware of where that hinge projection is going to stand and how it will possibly affect the proper opening, you know, of your door. So, you know, our hinge is 4.5 inch. 4.5 is when it's laid open. It's 5 inch tall. Now they'll make this hinge in a 4 inch tall, a 4.5 inch tall. Pardon me. They'll make a 5 inch hinge in a 4 inch wide, 4.5 inch wide, 5 inch wide, 6 inch wide, etc. But really, why did this client select 4.5? I don't know, except that most likely they simply selected it because it is, you know, a standard sort of width. But just because it's a standard width doesn't mean necessarily that it is the, you know, correct width that that would be used. And a little bit of analysis on, you know, how to select the width of the hinge, I think really is in order. So you've got your two studs, okay? You have your door. So in this sort of scenario, you're going to have your hinge. This sort of scenario, you've got your vertical axis of pivoting, your hinge barrel. In this scenario, there's no clearance requirement that you have to overcome, meaning the door is basically flush. Although it's not flush, it's basically flush with the face of the frame. That means the pivoting axis is residing out here, and the door will very happily swing to 180 degrees. There's no question about that. The issue, however, is a 4.5 inch wide hinge is actually not the best choice for this application, because the hinge barrel is, while it may not occur to most because we just don't notice it, it is actually standing it's standing unnecessarily too proud from the face of the door and frame. When you have a scenario where the door is flush basically with the frame and the wall I drew that wrong, forgive me. The wall construction is here, okay? A 4 inch wide would actually be considered best practice because you don't have anything to overcome. In terms of a wall thickness or a clearance. You get into a scenario where you have a very thick wall, and then your frame sits in here. Okay, so now we've got a different scenario. You know, the question becomes is, what degree of opening do you want? How do you want that door to swing? You want it to go to 90? Well, then this dimension of clearance, actually from here, doesn't matter if you are only going to take that door and you're only going to go basically from here you know, to here. If I were to take that and the leaf now becomes over here, my door is going to set here. So if you're only going to 90 degree, it doesn't really matter if your wall is this thick. But if you want to go to 180 degree, now you have to start to think about, okay, we need to move that vertical axis of pivoting over to get that door to be able to lay flat against the wall. So there is a formula for determining this, and that formula is it's very widely available online in a variety of different sources, and I always think of a particular manufacturer's catalog when it comes to determining the dimension required for wide throw, or what dimension of width of hinge you need to have. And it's right here. And let's study that for a moment. Let's take a little study into this. Basically, this type of diagram, like I said, you'll find in the industry, published all kinds of places. But it is the way in which we determine the proper width of the hinge. While the height is always scrutinized, we always make sure that we get the height correct, or at least we try to. We kind of ignore the width, and it shouldn't be ignored because, and the example in particular very much applies to a electrified hinge, which I stated earlier is not a load-bearing hinge. After you drill holes and run wires through it, a hinge is, once it's prepped for transfer, is simply not going to be... Okay, so studying this, it shows you this drawing, but really the formula is this. So, door thickness. Take your door thickness, whatever that is. Let's just say 1 3/4. Then let's subtract from that your back set. The back set is the amount of the door that has not been mortised for the hinge. So if I'm looking at the edge of a wood door, okay, and obviously the door, continues through here. It's really a solid line. So I'm going to mortise this back generally 1.5 inches. The back set, the amount of the door that's not been mortised is here. And if you have a wood door, you're not going to be cutting the hinge leaf all the way through, like you could see you will see on a non-handed hollow metal door. The amount of the thickness of the door that the hinge does not occupy is the back set. So take your door thickness, subtract your back set. Here's what it is. It's 1/4 inch. You should confirm, because it's not always 1/4 inch, but it's probably going to be 1/4 inch. So door thickness minus back set, 1 3/4 minus 1/4 is 1.5 inches, times 2 is 3 inch. Plus any clearance that you require. Plus any clearance that you require. So in our earlier scenario, where we had that wall condition, here's your drywall, your studs, okay, forgive the poor drawing, where you don't have a clearance, that dimension is 0. Okay, well, in the case where we have 8-inch block, 8-inch block is actually 7 3/4, 7 5/8. And we're going to take our frame and we're going to center it in the edge of that block, and we're going to use a T-anchor. Okay, so this, let's just say that this is 5 3/4. Let's say that you basically have 1 inch, like almost 1 inch. You have 1 1/16 really. 7 5/8 minus 5 3/4. What is that? 15/16 perhaps. Now let's just figure it out. 7.625 minus 5.75, if we've centered it, divided by 2 is 15/16. So in this scenario, our clearance now becomes 15/16. Okay, so back to our definition. 1 3/4 minus 1/4 times 2 is 3 inch, plus 15/16 plus your inset. If there is an inset on this hollow metal door, the door is not flush. The dimension from the face of the frame to the face of the door is the inset, and that's about 3/32 of an inch. Let's just call it 1/8 of an inch. So 1 3/4 minus 1/4 times 2 is 3 inch, plus 15/16 plus 1/8 of an inch. 3, so about 4 1/16 is where we are. Okay. inch and 3/4 minus quarter times 2 is 3 inch, plus your clearance, plus your inset. So it's roughly an inch. It's roughly an inch. Well, it's an inch and 1 3/16. So 4 3/16. You then use the next standard size larger. Okay, so that would be in this case 4.5 inch. So you can clearly see when you do not have an inset, you should be questioning, is 4.5 inch the best size? And in lots of scenarios, the answer is no, it's not. If you have knockdown drywall frames and typical partition walls, 4 inch wide is best practice. Now, as I said earlier about how it applies to this load-bearing hinge, you want to keep that vertical axis of pivoting as close to the center of the door as possible, because that hinge is more capable of carrying the weight of the door, which is centered all over here. You don't want to have that point of carrying all the load so far off the center line. Draw it back as far as you can. You're not going to get a 5 by 3.5 hinge, but you're sure going to get a 5 by 4, and that would be a way better use specification as a detailer, as a hardware distributor, as a specifier. Knowing the proper width to use is crucial because, again, in the instance of a non-load-bearing electrified hinge, a hinge that's been compromised, you want to have all of those, every possible advantage working in your favor. You're a specifier, you are a detailer, you are a distributor, whoever we are, we're all advocating in the best interests of the owner, and the best interest of the owner is to have the right hinge. And anyway, this would be a deep dive analysis on how to go about determining what is best practice. I stock 4.5 by 4s because I ship them standard in lots of applications. Why? It's a better hinge. Also, when you're walking down a hall and you've got all these frames that are wrapped over partition walls, you can really notice projecting hardware, and you want to keep projecting hardware at the minimum. Okay, if you've ever walked through a confined space and you've cracked the crown of your watch on something, I've done that on projecting hardware. You know, I've scratched my watch face. So we want to tuck that back as close as we can. So now that really covers the width discussion. Down here in the balance, we have extended description information. And let's just go over that quickly. Indoor use, yeah, these wires are not going to be rated for exterior applications. For doors requiring low voltage, current transfer capability only, must be non-load bearing, mount in center position only. You're certainly not going to put this hinge at the top. That would probably not be nearest where your power is, but you'll certainly, as we had said earlier, with 70% of the weight of the door being borne on that top hinge, you're going to want to bring that down. This is a steel hinge with a steel pin, and this is a 4-wire. Now let's talk about that. There are 2 pair or 4 wires running from one side of the hinge to the other. That means to me that you're only doing one job. You're only connecting one load with this hinge, because you will always want to have at least one pair remaining. And depending on how many things you're connecting, you might want an 8-wire hinge or a 12-wire hinge. A 4-wire hinge just simply means that you have a lock set with electric latch retraction, you know, and that's it. Or a request to exit switch, just one thing that you're wiring. You will never get a 2-wire hinge. They don't make those. And the reason there's always an extra pair is because these wires are just 28 gauge. They're 12-inch long, but they're 28 gauge, so they're very thin, and the potential to unintentionally break one, crimp one, compromise one is real, and it's been industry standard for countless decades that you need to have extra pairs built in, compliant with this ANSI requirement. You can look that up if you want. This is a template hinge, and a template. The word template simply means that the location of the holes in the hinge are in what we call the template pattern. They're in the template pattern. This link to the template is down below. The word template simply refers to the location of the holes for the hinge in the hinge leaf for a 5-inch tall hinge. those are going to be considered the template pattern. They're in a pattern that we define using the word template, and every hinge that has a template pattern will match these locations, regardless of manufacturer. If your doors and frames are prepped to the 5-inch template pattern, this hinge is going to work. Okay, so that discusses our template idea. Moving on, we have ball bearing. Yeah, we demonstrated that on this heavyweight hinge there were 4 bearing packets and that it was 5 knuckle. This features a non-removable tip and plug, and what that means is while this is not prepped as a non-removable pin in the conventional NRP prep where there's a hole drilled and tapped with a set screw, this hinge pin is of such design that the pin cannot be removed. Removing the pin would destroy the work done to make it an electric transfer style hinge. The thickness of the hinge is indeed 190 thousandths. We went over that with our caliper, and it's also going to be on the template right here, 190. This is important where you have, whenever you're connecting electrified hardware, you have to be mindful of the system and the system components and their ratings to handle current. So this hinge will handle 3.5 amps continuously, up to 50 volts, and up to a 16 amp pulse. So a piece of equipment like a Von Duprin solenoid is going to have a large inrush for, whatever, 350 milliseconds, something like that. And it will handle that huge inrush, 16 amp pulse, a third of a second sort of scenario. It will handle that. So be mindful of what you're connecting. I'm not sure to what reference the listed for security equipment AMQV is referring to. I'll leave that to my curiosity. Tested to UL 634 standard for safety connectors and switches, and meets the hinge requirement, ANSI BHMA A156 series, the .1 document. This has been UL cycle tested to 350,000 cycles, and Bommer tested the hinge to well over grade 1, 1.5 million. Okay, they show some details here in terms of options and features. I've never seen an electric hinge with decorative tips or a hospital tip. Reach out to us. I don't know if the factory can do that work. It's very likely that they can. It's possible that they cannot. But we have it listed there because this is just boilerplate coming from another description. Security options, security stud. I'm sure that this can be done with a security stud, and that is a means by which, should the pin be driven out, there's a stud that fits from one leaf into a hole prepped in the opposite leaf to prevent the hinge leaves from being separated in terms of being sheared apart when the door's in the closed position. There is a reference to radiused corners, and that is possible to do on these hinges. We've done some unusual hinges like heavyweight ball bearing hinges with radiused corners. 5/8 actually have done this size hinge and a 5/8 radius. Now, other supporting documents that we have listed here. Let's look at the cut sheet, and that is okay. We've got the proper document pulled up here, and it's going to be called Door and Frame Preparation Template, or Door and Frame Through Wire Template by the time you're seeing this video. And that shows you where to drill the 5/8 hole to pass the wires through. Right in the center, the vertical center of the hinge at 0.6 inch back, so just shy of 5/8 for this 5-inch hinge. There's also the installation instructions. This is handy. This is actually a scan of the actual document that you get. That's a little bit tough to read, I suppose, here, but it's certainly you can certainly make it out. So they're talking about the different models this applies to, for use with 4, 6, 8, 10, and 12 wire through wire hinges, steel hinges for interior use only, They can do hinges for exterior use, and that would be a brass or a stainless base material. They also sell you a mortar guard, and that's a piece of steel that has been prepped to be attached to the backside of the frame to not only cover the leads of the hinges coming out of the back of the hinge, but also give you a way to transfer them as well. And then again, they give us the rating of the electrical profile of the hinge. 28 gauge, typical for all models shown. So we're doing a 4-wire. You'll have a red, yellow, violet, and gray. Yeah, that's certainly what our hinge here is, and we'll go over that in a moment. Shows you all the way up to 12 wire, how those will be indicated. Page 2, door and frame must be prepped in accordance with the through wire template, which is also linked to up above. They're not load bearing. Don't take it apart. Wire access holes must be free of burrs and sharp corners. Make sure everything fits correctly. Hang the door on the top and bottom hinges first, and those would be the non-electrified or non-transfer hinges. Attach wires in accordance with project wiring diagrams. Open door to 90 degree or more for access to jam preps. Extract interior wiring through the prep hole in the door and frame. Terminate wire connections with appropriate crimp splicers or wire nuts. That's not included with the hinge. Do not hang onto the hinge by just the wires alone. They'll certainly become damaged. Insulate all ends of unused wires, naturally. After all terminations are complete, carefully slide wires through the prep hole, making sure that the wires are placed so they will not be cut or pinched as the hinge is installed. Okay, so that talks about the overall aspect of the hinge when it comes to making it, appropriate for your installation. Sorry, getting back to our page on our hinge. Okay, so this wraps up all the supporting documents, and let's finish up this video on camera. Okay, now to finish up the hinge that we're talking about, the fact that the pin is not removable, there's not even any access to here. They clearly have a roll pin inserted here to make that part of the pin non-removable, and another one up here. That's certainly by design. Swings very smoothly. Okay, now here's the back of the hinge and the 4 wires. They said it was gray, yellow, violet, and red, I believe. With a 12-inch lead, I want to get those carefully pulled out. Okay, here we go. A rubber sleeve to keep the wires protected. Okay. Going to put that back together. Now the balance of the extended description, we've covered everything that is on that document. And a 4-wire hinge, again, probably going to be just for a request to exit switch or maybe electric latch retraction. That's it. Nice quality hinge. Satin chrome finish. Obviously, they can do this in a variety of different finishes. I have been to Bommer's hinge manufacturing facility and their plating plant. They quite proudly will tell you that they can do 33 different finishes. Now, they would be able to do 33 finishes on this hinge because that includes brass and stainless and bronze and steel base materials. But onto steel, they can... they can plate anything on here. All your common finishes, your chromes, your brasses, your nickels, your bronzes, satin, polished, oil rubbed, whatever you can do on steel, they can do. Obviously, prime coat, bright black japanned, zinc, so they can do it. This just happens, of course, to be satin chrome. Okay. Last thing I'd like to point out to you is the Bommer logo, and right above it, it says Made in USA, a fact that Bommer is quite proud of, as am I to represent them. Any questions on the Bommer BB5064 BB5064-545ETW04 in a 652 finish. Please feel free to reach out to us. This is going to include 2, 4, 6, 2, 4, 6, 2. Well, this has all machine screws, 2, 4, 6, 8. It has 6 wood screws, so I would think that they meant to send half wood screws. In the comment field, absolutely define what you'd like. All wood screws, all machine screws, half and half. You don't want to get to a job and not have the appropriate quantity of screws. I know that this is a steel door and a steel frame, so I'm not concerned about the wood screws being inadequate, but you know, if you order this and it's a wood door and a wood frame, definitely specify all wood screws in the comment field. You know, it's a 12 by 1.25 inch threaded to the head, flat Phillips drive screw, but there's no reason for you to have to run around looking for screws at the last moment. The machine screws are 1224 thread forming, flat undercut head in a complementary finish. Again, any questions on the Bommer BB5064 or any other Bommer product, please feel free to reach out to us. And thank you.